Okay, welcome to the lesson on the slope of a tangent, part 2. So what we're going to do is we'll just do some more examples on this concept of slope of a tangent. So in this question, we're asked to not only find the slope of the tangent, but find the equation of the tangent. So you should know that the equation will be a straight line. So let's draw it actually. So hopefully we recognize this is what type of curve this is. There's an asymptote at 1, and it would look, the y-intercept, in fact the 0 would be 2. There's horizontal asymptotes of 0, so it looks something like this. So we want the equation of the tangent, so that's this line here. We want to get the equation. So it's a straight line. Well, what do you need to get the equation of the straight line? First, find the slope, right? In order to get the equation of a line, you always need to find the slope first. Well, that's what we were doing before, right? That's that new formula. So we know that m is equal to the limit as h goes to 0 of f at a plus h minus f at a all over h. So where a is 0 and f is this. So the limit as h goes to 0 of, so now I'm just going to put 0 plus h into this. So it would be 2 over 1 minus 0 plus h, I'll just write h, minus f at 0. So that'd be 2 over 1 minus 0, all divided by h. Space is going to be an issue. So the limit as h goes to 0 of, so this would be 2 over 1 minus h minus 2 all over h. Now what are you going to do? Try direct substitution. This would be, if you put 0 in here, you get 2 minus 2. That would be 0 over 0. So you can't use direct substitution in determinate form. So you need to do something else. When you have a rational, a common strategy is to first just try getting common denominator on the top. So the common denominator would be 2 minus, be 1 minus h. So that's the common denominator on the top, so I just need to multiply 2 by 1 minus h, and then that's all over h. Expand, I'll do it over here. Expand the numerator of the numerator. So 2 minus 2 plus 2h all over 1 minus h. And then that's all over 1, that's all over h, but just to get rid of all these fractions, I'm going to multiply by the reciprocal. So I can this is this h, right? I just multiplied by the reciprocal instead of dividing. So that's the limit as h goes to 0 of, and now these 2's go away. So we've got 2h all over h times 1 minus h. These h's go away. So 2 over 1 minus h, and now notice direct substitution will work. So you get 2 over 1 minus 0, which is 2. So that's your m. That's your slope. So the slope of this line is 2. So we know m equals 2. What else do you need to get the equation of a line? You just need a point. Well, we know that the x value is 0. We weren't given the y value in this case, right? A lot of times you're given the y value, you'd be given a point, but here we're not. So in order to get the y value, just sub this into here, right? So if y equals 2 times 1 minus 0, y equals 2, so our point is 0, 2. and then use whatever method you like to get the equation of a line. So a lot of people like y equals mx plus b. M is 2, x is 0, y is 2 plus b, 2 equals 0 plus b, b equals 2. So therefore, the equation of the tangent would be y equals 2x plus 2. So that's the equation of the tangent to this curve up here at this point. Okay, here's another example. So we want to find the slope of the tangent, done that before, to this curve at an given 3 points. So how would you do this? Well, we could do that formula 3 times, right? With these are our a values, 0, 1, and 2. That's going to be kind of annoying, right? So to save us some time, instead of doing it at these specific points, find the slope at a general point. Find slope at point, let's let our x value be a, and our y value then would be f at a, or sub a into there. So a squared minus 2a. So then m would equal the limit as h goes to 0 of, well, I'll just write the formula down right now. So f at a plus h minus f at a all over h. So the limit as h goes to 0. So f at a plus h is going to be a plus h in here, right? So a plus h squared minus 2a plus h minus f at a. F at a was just this. Put it in a bracket. All over h. Limit as h goes to 0. So how am I going to solve this? Try direct substitution. If you do, you'll get 0 over 0. So can't do that. So let's try expanding this. So we get a squared plus 2ah plus h squared minus 2a. This would be minus 2h minus a squared plus 2a all over h. And now what you're going to notice is some good stuff starts happening. A squared minus a squared. Minus 2a, 2a. So now notice what we're left with. Limit as h goes to 0 of, I'll just write this out, 2ah plus h squared minus 2h all over h. So what do you notice about the top? There's a common factor of h. So do that. Common factor the h. 2a plus h minus 2 all over h. Those go away. So you end up with limit as h goes to 0 of 2a plus h minus 2. If I let h go to 0, I'll have 2a plus 0 minus 2. So I'd end up with just 2a minus 2. That's the slope. So let's write this up here. So m equals, was it 2a minus 2. So that's the slope at this point. Well, now remember we were asked to do it at 3 different points. So now if I want to get m at 0, 0, all I have to do is, this is our a, right? This is a. So m would equal 2 times 0 minus 2, which would be minus 2. M at, let's do the next one, 1 minus 1. So m would equal 2, a is 1. So m would equal 0. And then m at 2, 0 would be m equals 2 times, the next point was, oh sorry, right there, 2. So 2 times 2 minus 2. So m would equal 2. So that's the slope at all three of those points. So you can hopefully see that this is a little bit faster, right? Instead of doing it at 3 different points, doing the formula for 3 different points, do it once at a general point, get your answer, simplify it down, and you end up with this. And then you can just sub in these points to this new sort of formula or equation for slope. So it saved us a little bit of time. And that's the end.